Data structures in C, linked list implementation of a queue. You're already familiar with the queue. We have already done the array implementation and circular linked list also using array implementation. In this lecture, we shall deal with the linked list version of a queue, which is far better, I would say. Uh, So therefore, we will implement the linked list version of queue and write functions enqueue, dequeue, etc. to input data items and delete a data item from the queue. You are familiar with the operations on the queue. As you know, it is first in, first out module. So this is where we input at the rear, we input insert item and we remove items, delete items at the front of the linked list. We have front and the rear or the back. So let us see and try to understand linked list again. As you see, this is the front, this is the rear, and we add items at the end, rear of the queue. And as I said, the items are removed from the front of the queue. So we remove this item and make the next item the front of the queue. So this is the procedure we are going to follow in connection with the queue. So now the question is how to create a pointer to a structure. These are the pointer basics we have gone through earlier, but I want to repeat it so that people understand. So as you see, we have here a data structure or a new data type called QUEUENODE, which contains a number and a link to the next. It is pictorially represented here. It is pictorially represented here, number and a pointer to the next. Next is how do I create pointers of the type QUEUENODE? Just put star node and star p. Node and p are two pointers. Next question is how to assign a value to a variable in a structure pointer, which you are familiar with already. So node arrow number equal to 30. So always when it is a pointer, I use arrow. If it is just a variable, I put a dot there. Since node is a pointer, I say node arrow number equal to 30. In other words, 30 is assigned to this variable number which is pointed to by this pointer node. Similarly, I say next equal to null, next equal to null. And this is how we allocate memory of the type of QUEUENODE. As you see, QUEUENODE star here, that is, we indicate that it is a pointer, and therefore P is going to contain the address of this node, this node. So suppose I can say therefore P arrow number is equal to 25, P next is equal to null, and then I say node next is equal to P. We have got node here and it was null here. I am assigning the address of this P to next. In other words, this node and P are linked. Node comes first, P comes after that. So this is how we link these nodes one after the other. That is what we are going to do when we are going to insert or enqueue data item into our queue. Again, this is pictorial representation. This is how we create a new data type called QUEUENODE, and then this is how we create a pointer called node, allocation of memory which you are familiar now, and then assigning these numbers. With that I create a node with 30 as the number data item which points to null. With that we come to the first function we want to write a function subprogram in C to create a node of Q which will return the address of the node. It will load that number data item and it return the address. Again, you are very familiar. So Q node star make Q node. That means I make a Q node out of this number. So allocate memory here. This is the local variable node. When you allocate memory, this node is going to contain some address, and then you are assigning number and null to this node, and return node. It returns the address of this node which contains the data item number and which points to null. For example, here we say make Q node 80. 80 is going to be the data item in that node, then this node here contains the address of this node, which contains 80 and points to null. So with that we come to creating a queue. And as you know, when we create a queue, we have got the front of the queue and the rear of the queue. Now we are going to simplify in this. So what we shall do is we will create the if there is no, for example, case 1, queue is empty. That means front points to null. When initializing, I say front is equal to null. Therefore, front points to null. There is no queue. Therefore, the incoming node is made the head, the front of my link queue. So this is what we are going to do. Create a new node with data, and then if the front of the queue is null, make that node the front. For example, here I have created a new node which contains 30. Then I assign the address of that to front, and automatically earlier front was pointed to null, now front is pointing to this node and it points to null. Therefore this queue contains at the moment only one node. Now case 2 would be, as you see here, node, I've created the node, I have assigned this number to that node, and if front is equal to null, front is equal to node, so I have assigned that node and return. Of course, instead of writing this code here, we are going to make use of that function, make queue node, and assign that 30 to that. That is what we are going to do in our next function. So this is what we do in case 1, when there is no queue or the front of the queue is empty or it is null. Now we come to case 2. There are only two cases. Case 1, when there is no queue. Case 2 is there is a queue. Then what am I going to do? How am I going to add the new node to this? To do that, what we do is we are going to have two versions. This is a simpler version. So what we are going to do is I have the address of the front. So from there I go on searching for the end of the list, that is queue, and when I reach the end of the list, I attach the new node at the end, because as you know, we insert the new node at the end of the queue and we delete the first node. So that is what we are going to do. So therefore, I come to here, I search, I traverse this list and come to this last node, which is P or previous, and then I have got the new node. What I do is I attach this new node to P, that is P next. Here I have come, this is previous. Previous next is, or current next, previous next is equal to node, and automatically this is going to be removed. This way I have attached the new node at the end of the list. So these are two cases. Case 1 is there is no list queue, therefore the front is null. I make the incoming node the front. Otherwise, I traverse the list. I go to the end of the list. When current becomes null, I've got the previous. I say previous next is equal to new node, and then with that I attach to the node. That is what we are doing. I'm assigning all that this could be done. So front to P, and then I say as long as P next is equal to null. So P is equal to P next, or current is equal to current next, and then you say P next is equal to node. You can do either this, either just taking one variable, or you could also take previous and current, and then you attach, when current becomes null, you attach the new node at the end of previous. So previous next is equal to node. So this is what we have done here. So NQ, this is NQ, NQ. So create these two nodes, then make a new node out of this number. So then assign front to P, and then you say front is equal to null, make that incoming node the front of the node of the list. Otherwise you traverse the list. P next is not equal to null. Traverse the list. So P is equal to P next. Then what happens is P next is null. Therefore, P is there. So I attach the new node at the end of P. P next is equal to node. And this is how we insert data item into a queue. We come to this next function. So we have all two functions, one to insert a node into the queue, other one is to delete a node or dequeue. Dequeue means very simple, we are deleting the first node, the front of the list. So how do I do? First I want this number, so therefore assign this number. Number is equal to front number, so it goes in there. Then what do you do? Now number is there, so front is pointing to this number, this node which contains. Now I want front to point to the next. So what do I say? Therefore I say, I assign therefore front to p. Then I say front is equal to p next. This is p next is assigned to front. So you could have said also front is equal to front next also, but this is easier way. So you assign therefore the front of the queue to a variable called p pointer, and then say front is equal to p next. So automatically it is going to point to the next node. Then you have to free that. P. You should not leave that node like that. So you free the p and you return. Automatically the first node is removed and the front points to the next node of my list. So again here the code for dequeue. If front is equal to null, you say queue is empty, return -1. Otherwise, you get the number, then you say front is equal to p next, and you decrease the capacity, because if you want to keep a limit on the number of nodes in my queue, I need to use a variable called capacity to limit the capacity. Then you say free p and return null, return number. So print queue, very simple. I want to print the contents of my queue. So what do? I start with the front, print the content of that. Then go to the next one, p next, I print the content of that. Go till I come to the end of the list. As you see, assign front to p as long as p. Instead of p, you can use also current. So you assign front to p as long as p is there. So what you do? You say print the number, go to the next number. Print the number, go to the next node. And when it comes here, p next is equal to null, it will come out of the while loop. So this is how you print the content of your queue. So first you check again if front is equal to null. So you say is empty, return. Otherwise you assign front to queue or p or whatever it is, or current, and then you print the content of that. Go on doing it till you come to the end of the list. So this is the main program. So I've got my new data type. I've made a front as my variable, and I've got one more variable called capacity to keep check of number of nodes in my linked list. So these are prototypes of the functions: make queue node, enqueue, dequeue, print, menu, init queue. So these are you're familiar with. Init queue is going to make this front is equal to null. So this is the main program. So with you call the menu, you have got different options. Option 1 is enter a number, option 2 is delete a number, option 3 is print the queue, or 4 is equal to exit. So here you have got these function. Enqueue, complete enqueue is here. If front is equal to null, make the new node as the front, capacity is equal to 1. If capacity is greater than size, I'm checking here, so I can, so then you say queue is full and you come out of that. Otherwise you traverse the list and then add the new node at the end of the list. This is what you are going to do. So again, this function you are familiar with. Dequeue, init queue, front is equal to null, capacity is equal to 0. This is the function to print the content of the queue. So these are some examples I have given here. So you could do workouts. For example, you entered 3 choice is displaying the content of that. Then here, for example, I'm entering T2 delete. So it is deleting the first node and giving you the number. And then it is again entering, displaying here the content of that. As you see, 23 is removed, 5612 is there, 89 some other. Then we have added 178. So enter a number I have added here. So then capacity is 5. So here it immediately it gives you added extra. Choice is 1. So it says queue is full. So thank you.